In the last episode, I told you that I'm about to take a giant leap, creating my very first hardware product, a solar-powered weather station. Today, I want to bring you behind the scenes of how I designed the very first prototype. I'll walk you through the tools and software I used, the components I picked, and the full process behind my design choices. My hope is that by sharing my journey, including the struggles, you get insights that help you make smarter technical decisions in your own project. Sounds good? Let's dive in. Now, let's be real. Building a tech product isn't just one project, it's like 3 projects in one. To make my weather station a reality, I had to break it down into 3 big parts: electronics, mechanical structure, and coding. Each of these comes with its own challenges, but the hardest one for me, by far, was electronics. My background is in coding, not circuits. I can make software dance, but when it comes to resistors, capacitors, and PCB trays, I'm very much a beginner. Still, I knew I couldn't avoid it. If I wanted my dream project to exist, I had to face electronics head-on. To build up some foundation, I picked up the book Practical Electronics for Inventors. It's a solid resource, very detailed and with a strong reputation in the electronics community. Even though the title says practical, it's actually pretty theory heavy. So it's not exactly a learn by doing book. It gave me enough knowledge to at least understand what I was dealing with when it came to current, voltage, and circuit design. With that, I started thinking about the electronics of my weather station. My first idea was simple: just hook up sensors and modules to an ESP32 board. The ESP32 would act as the brain, collecting weather data, processing it, and sending it whenever it needed to go. But here's the problem: if you try to wire everything up with jumper cables and breadboards, connections get messy really quickly. One loose wire and the whole thing stops working. That's when I realized if I wanted this project to be solid and reliable, I had to design my own PCB, basically my own custom shield to connect all the modules directly to the ESP32. Yes, my first ever PCB. Before showing you how I designed it, I want to back up for a second and explain why I chose the components I did. So what I'm building again? A solar-powered weather station. That means the system not only needs to measure weather data but also run continuously on solar energy. Sounds cool, right? But once I actually dug into the details, I realized powering a device with solar isn't as simple as slapping a panel and a battery together. The whole system needs to work like this. During the day, the solar panel has to recharge the battery. The same battery then powers the weather station. The device energy consumption during the day must stay below what the solar panel can generate, otherwise the battery drains out. At night, the station still runs on the stored energy, so it can't consume more than what the battery saved during the day. If any of these conditions fail, the station shuts down. No more data, no more forecasts. That's why energy management became one of the most important and most challenging parts of the design. While searching for solutions, I came across something really interesting on electrical website, the ESP32S3 Power Feather. This small board is basically an ESP32 that's being optimized for low power applications. It already has built-in circuits for minimizing energy consumption, a connector for solar panels, a battery monitoring system, and more. It was basically designed for the exact kind of project I was building. So I grabbed the full kit, the ESP32 itself, the proto wing shield, and the solar panel. With the brain and the power system figured out, I moved on to the sensors. I decided to use BME 280 for temperature, humidity, and atmospheric pressure, light sensor to measure sunlight levels, MK9 gas sensor to detect carbon monoxide, UV sensor to measure ultraviolet radiation. On top of that, I added 2 LoRa transceivers for long-range wireless communication and a 5-inch capacitive display so I could visualize the collected data in real time. Of course, to connect all these sensors and modules neatly to the ESP32, I also needed a custom PCB, and to house everything, a 3D printed enclosure. So just like that, I had the shopping list for my first prototype. Now you may be asking, where did you get get all this gear, and wasn't it expensive? Here's the truth, the power feather solar kit I bought myself, but all the other components, the sensors, the LoRa modules, the display, the PCB, and even the 3D printed enclosure were provided by Electro, the sponsor of this project. If you don't know Electro yet, they're a global provider of open source hardware and manufacturing services. They've been serving the maker community for over a decade, helping people turn their ideas into real products. They offer PCB manufacturing, 3D printing, injection molding, assembly services, and even a marketplace where you can sell your creations. Basically, they're the kind of partner you want if you're building prototypes or even finished products. I honestly can't thank you them enough for supporting this project. If you want to check them out and maybe even start turning your own ideas into reality, there is a link in the description. Just drop them a message, they will be happy to help you. Thank you Electro for making this dream possible. So where am I at right now? Does the weather station work perfectly? Is it finished? Not exactly. Like any prototype, some things worked as planned while others failed completely. And that's okay. Prototyping is about learning through trial and error. In fact, I'm already planning the next version of this design because one prototype is hardly enough to get something working continuously in the real world. But I won't go into all of that today. I don't want to overwhelm you with too much at once. Instead, in the next episode, I will reveal exactly what failed, what works surprisingly well, and which design decisions I'm going to keep moving forward. That's where things start to get really interesting, because you see how theory meets reality and how failures can actually point you in the right direction. And before we go, if you are interested in this project and want to be the first to know when the weather station is ready to launch, I've set up a waiting list. You also get some extra business tips I've learned along the way. The link is in the description, and don't worry, I won't spam you with random emails. Alright, that's it for today's episode. I hope you find it useful and maybe even a little inspiring. If you can't wait until the next episode, check out the video that's on the screen right now. I'm sure to give you ideas to level up your maker skills. Thank you so much for watching, and I'll see you in the next one.